Hello everyone. In this video, we'll be seeing about the classification of electrical networks. So here we have a pictorial representation of the classification of various electrical networks. We have linear network, non-linear network, then we have unilateral network, bilateral network, lumped network and distributed network, then we have active network and passive network. So first we'll see what are linear and non-linear networks. So here it is a pictorial representation for the linear versus the non-linear networks. You can study one and you can write the opposite of that for the other one. So here what are linear networks? A circuit or a network whose parameters. Now what are the parameters? Parameters like resistance, inductors and capacitances, these will be always constant. Okay, constant irrespective of change in time, voltage and temperature. So here in linear network, the parameters such as resistance, inductance and the capacitance, irrespective of change in the voltage, temperature and time, will be constant. Fine. Such a network is called as the linear network. And here for such type of networks, Ohm's law can be applicable or you can apply the Ohm's law. And here the mathematical equations of these type of networks, that is the linear networks, these can be obtained by using the superposition laws. Okay, so here this will follow the laws of superposition. And the response here, the response for linear networks, it will be linear with respect to the input which is applied to them. Fine. So what are linear networks? Linear networks are those whose parameters such as the inductance, resistance and capacitances are always constant. Okay, irrespective of what? Irrespective of the change in time, voltage, temperature, etc. And here we can apply the Ohm's law for such type of networks, and also the mathematical equations of the linear networks can be obtained by using the superposition laws, and the response to such type of such types of network elements, it is linear with respect to the input or the excitation which is applied to them. Now we'll see what are non-linear networks. So here, what are non-linear networks? Here we were having the constant parameters, but here the parameters will be variable. So non-linear networks are those whose parameters change their values with change in time, temperature, voltage, etc. Okay, so what are non-linear networks? Non-linear networks are those whose parameters will change, will have a change in their values with the change in time, temperature and voltage. Okay, there may be other factors also, and here we will for such type of networks we cannot apply the Ohm's law. That is Ohm's law, it is not always possible or it is not always applicable to such type of networks, and the mathematical equations for non-linear networks, these will not follow the law of superposition. And also the response, okay, the response of such type of networks, it is non-linear in nature. Example is a circuit which will be consisting of a diode, okay, where the diode current will not vary linearly with the time, linearly to the voltage which is applied to it. Fine. So this was about the linear versus the non-linear networks. Next we have another type, or you can say the combination of these two, which is based on the direction of the current. So we have here bilateral network and the unilateral network. So bi is nothing but 2. Bi means 2. So here a circuit whose characteristics and the behavior, it is same irrespective of the direction of the current, okay, through the various elements. That is called as a bilateral network. And here this type of networks, these will be consisting of only the resistors. Okay, so here that is called as a bilateral network. What is a bilateral network? A circuit whose characteristics, behavior will be same irrespective of the direction of the current through the various elements of it. And here example for such type of network is the network which will be consisting of only resistances. Okay, then next is the unilateral network. So unilateral network, uni means one, that is single. So here a circuit whose operation behavior, it is dependent on the direction of the current through various elements, that is the current will be flowing through only one direction, and the circuit will be and the example is the circuit which will consist of the diodes. Okay, the circuit which consists of a diodes, it is a good example of a unilateral network which will allow the flow of current in only one direction. Okay, so the flow of the direction of the current will be in a single direction, that is called as a unilateral network. The next combination is the active and the passive networks. So here you will be having the energy sources and the components. Now what are active networks? Okay, active network, it is a circuit which will be consisting of the voltage source and the current source. Okay, that is, it will be consisting of at least one of these two sources. Either it may have voltage source or it may be having the current source. It must have at least one source of energy. It may have two also, but at least one source of energy must be present in an active network. So this type of network, it is a active network. Here you have the voltage source, you also have a current source along with the network elements or the electrical parameters. Okay, so this is a active network. Now what is a passive network? A circuit which has no energy source, but it will be having either resistors, capacitors or inductors. So such a type of network, it is called as a passive network. So here this is an example of passive network where you don't have any energy source. In active network you will be having energy source, whereas in passive network you don't have any energy source. Next is lumped versus the distributed networks. So here what is a distributed network we'll see, and what is a lumped network we'll see. Now lumped network is a network in which all the elements are physically separable. Okay, that is, the elements are physically separable, and here most of the electric networks, these are lumped in nature, and these will consist of what? Resistor, inductor, then capacitor and the voltage sources, and here the elements will be discrete. Okay, this is lumped network. In lumped network, what you have here, the network elements are physically separable, and most of the electric networks are are lumped in nature, which will be consisting of what? Resistor, inductor and the capacitor, and also the voltage sources, and here the elements are discrete. Next is the distributed network. Here the elements are not separable, that is, these are non-separable. You cannot separate the elements. Example here is the transmission line parameters. Okay, and here in transmission line parameters, the resistance, inductance and the capacitance, these all are distributed along the length and the length of the transmission line, and these cannot be separated. Okay, so here it is distributed, here it is not discrete. Okay, so this is about the lumped versus distributed networks. In lumped network, the elements are physically separable. Okay, and the common elements which are used are the resistor, inductor, capacitor, voltage sources, and the location of the elements is discrete. Whereas the distributed network, the elements are physically non-separable, and here the elements are like distributed along the length of the transmission line, and the element location, it is distributed. So this was about the classification of the various electrical networks. Thank you.